Alright, as usual, my channel smooth sailing, no begging, no selling, just straight to the point usually. Going to talk about why I chose an interlock system for running a generator to power most of the house versus a transfer switch. An interlock system is primitive. It's just a high quality aluminum plate. You you drill 3 holes into the metal panel after taking it off, and then these loosely slide up and down. This plate slides up and down so that you cannot have the main from the power company on and the generator breaker on at the same time to avoid feeding back power into the grid, which could possibly damage equipment or worse, kill or injure a power company worker. The reason why I like this compared to a transfer switch that I used to have, which is a sophisticated array of switches and breakers and all that, is several reasons, and it's hotly debated apparently, but my experience is the interlock system is much better, and the reason is because where there was a transfer switch here, it's lettered A through F, G through I, or whatever, and that gets confusing trying to figure out how to hook that up, and it ends up causing some inefficiencies and more room for error when you have so many more wires in the transfer switch going in and out of the breaker box. The transfer switch is more expensive by far, typically $300 on up for one of those, as opposed to this is about $30, and then the breaker about the same cost. And mainly why I like it is because you don't hear this anywhere else, but I simply label the breakers that I can use all at one time with my generator. So the one I have on order that will arrive shortly is going to be 6,000 watts continual running, and so my water heater is rated at 5,500 watts. I know that a generator that's rated at 5,500 watts continuously won't be able to power this, because I've already tried. Even with everything off except for the water heater, 240 volts, it still couldn't do it. So I'm going to try 6,000 plus this next time. And what I can do is simply label, you can choose whatever color you want. I chose blue so it's not so loud and still visible. Blue on black, you can see it. That's better than dark blue on black. Plus this blue electrical tape. Probably should use 2 layers so it's a little brighter than that, or a brighter blue. Anyway, the point is, so that when there's a power outage, all I have to do is switch off the breakers of devices that I don't have to be running during a power outage. For example, in this case, even if it's hot and humid, I don't need the whole house air handler and air conditioner because, well, number one, it would take quite an enormous generator to power those, but the reason I don't need them because I have a 14,000 BTU dual inverter air conditioner in the middle of the house that can keep the house cool off of just one 20 amp breaker, or even a 15 amp breaker with nothing else on it. But in this case here, it's this one right there that's shared with office room outlets, so I have to be careful not to have too much more than 4 amps running the office equipment when the power's out. And what I like about this system is since there's no simple, quick, easy way to explain it, but I'll try my best, is you see this water heater uses 5,500 watts. Well, my generator that's coming in is 6,000 watts, so it can basically only power just that at one time. So if I want to take a hot shower without using the camper vans, so if I want to take a warm or hot shower without depending on the camper vans and the luxury of the home, because it may be hard to do that in a residential area without somebody seeing me. All I have to do is shut all the other breakers off except leave the water heater on for maybe a half hour, and then turn off the water heater breaker and then turn all the blue ones back on, and then I can go take a nice warm shower. So it's only about a half hour of having everything off to heat up the water. You can't do that with a transfer switch. Not so easy, because the transfer switch isn't going to have everything, all of your breakers available, all of this available into the transfer switch. This would have to be pretty much duplicated over here for you to be able to pick and choose what you want to run. And I just like having that more control over what's going to happen. And some of the older transfer switches don't even recognize whether there's power from the utility company coming in or out. Like the old one I had here was so dangerous that I just took it out mainly for that reason. And then I realized, well, this is actually better. One advantage of having the generator have its own breaker is because I can avoid overloading the panel, because 2 spots have to be reserved for the generator power coming in, and if that weren't there, I would possibly hook up too many breakers and go over the 200 amp limit of too many things running at one time. So in order to free up space, I just bought a few more of these double breakers, but the panel has a limit on how many of those you can put in. With this panel, I had to put them on top. The manufacturer of this Interlock system, which is kind of a funny name for something so simple, actually shows the instructions of everything upside down. This brand of a panel typically, I guess, is mounted the other way, and so I've already turned this sticker upside down because it was the other way. Yeah, so in summary, personally, I don't see any need for a transfer switch when you can just simply put these 2 pieces in there and just mark what your generator can have. If the power goes out, just simply shut off your things that would overwhelm your generator. Your generator is not going to explode or anything if you accidentally leave these on, but doing that enough times, it could damage something, either the air handler in this case or the generator, by having under wattage to it. So I'm making sure this time to get a generator that puts out 240 volts. And another thing I wanted to get at, you might be wondering, well, why don't I just get a 12,000 watt generator? And there's maybe two main reasons why not. The first reason is because of gasoline consumption. So, storing gas for a long time, waiting for a power outage, that gas can go bad. And look at all those. I had more. I already gave at least one away. You don't want to be storing gas for a long time without a special additive, or at least pay extra for ethanol-free gas, or both is preferred. So the larger generators are much less fuel efficient because, well, they're just bigger engines, and so they're going to consume the gas a lot quicker, and during a power outage it may be difficult or impossible to find gas. So you're dependent on what you had stored before the power outage, sometimes up to a week before the power outage, or even longer if there had been like like a 7-day or longer warning a big hurricane is coming, and everybody's buying all the gas up, and there's nothing left. So anyway, so that's the number one reason: fuel efficiency. The huge generators will typically run maybe 8 hours on 10 gallons of gas, versus the one I ordered is 6,000 watts, roughly half the size engine, and so uses about half as much gas. So instead of a 12,000 watt generator powering the water heater plus everything else, I just simply keep the water heater breaker off and run the 6,000 watt generator. And when I'm ready to take a shower, turn everything off, turn that on, wait about a half hour, turn it off, turn everything back on, and then I'll have a generator that can run twice as long as the bigger generator, and I'm conserving a lot of gas. The second reason is because the larger generators are louder than the smaller ones generally when comparing the same quality. So generally you can get a 6,000 watt generator that makes the noise of about 70 decibels, as opposed to a 12,000 watt generator that will probably put out about 80 decibels. And there's a big difference between 70 and 80 decibels when it comes to generators, at least. But that decibel rating is not real accurate. It just gives you some clue, because there's not a standard as to how they measure the decibels. If I didn't, I may have mentioned it before, the transfer switches are identified with alphabets A through Z or whatever for the switches, and then the breaker box is numbered, not as clearly, but starting here 1, 3, whatever. I ignore the numbers. I am completely against cross-referencing like this, having the numbers that you cross-reference over here. This is when the house was built. They wrote all this, so this is all obsolete because I've already rearranged everything. So what I did is I went on my computer. Come on, Tidy, you don't want to miss this. You got to see everything that's going on. On my computer, I used OpenOffice free software. That's a Word knockoff. And I made 2 columns. So on the left side of the panel, I have everything listed here, and on the right side. And then I printed it on photo paper, which I wouldn't do again because it smears too easy. So just use something like stock card and print it and cut out each piece, and then use double-sided tape to affix these identifiers on each breaker. You have to be careful not to print too wide or too big, so it's kind of a delicate thing here. And then I made red some things to let me know of the really high power appliances, and I even went as far as figuring out how many watts some of the things use, and also the generator box outside has a 7,500 watt maximum at 240 volts and half that for 120, but I won't be using the 120 because I have 2 appliances that I will be running off of the generator that are 240 volts. I can do nothing about it. Number 1 is going to be the well, so I can get some water. And that has significantly influenced what kind of generator I got, is this well. I could do without the water heater, because if I can pump water into my RV, I can take a shower there. But since I'm already going to have 240 for the well, I might as well get one big enough that can power the water heater also, if that makes sense. And so what I would normally get if I could get away with 120 volts is a inverter generator, because that would be better for things, especially devices like the laptop computer and this monitor. an inverter generator. Yeah, inverter generator would be healthier for a laptop computer, but this is just for emergency power outages mostly that are typically around here something like just a couple days. After Hurricane Ian, my power was only out for basically 2 days, 3 days at the most. And so I'm thinking that they're getting really good at restoring it quick. So the chances of needing a generator here, I would have to pretty much have maybe a category 5 or 6 hurricane hit a very particular way through here again, and even worse than Ian, to knock out the power here for very long. There are still some people without power, and it's already October 17th, several weeks after the hurricane, for various reasons. So it could happen. But anyway, so 240, I don't like dealing with it, but I feel like just to get water, since I don't have city water, it completely influences what kind of generator I chose and how big of one I chose. All right, girl, I'm going back in the garage. You don't want to miss this. Yep. You're going to want to be sure to see what's going on in the garage. Yeah, come on. Come on, you don't want to miss this. Yeah. All right, so that pretty much covers everything. I'd like to cover this up, but I'm just going to keep it there, I guess, for nostalgia purpose, just to be able to refer to the way it used to be long ago, 2004. Because sometimes I like to kind of study this and figure out how they hooked this up before. It's interesting. Look, they have 4 slots for the dryer. I don't know what they were doing there. 4 for the water heater. That doesn't make any sense. And then 4 for the well. That does make sense, sort of. What that actually is there was 240, so 2 slots for the well and 2 slots for at that time, the water softener, which I don't have an electric water softener anymore, so that's an available 240 that I have, 240 lines going out to the house. And I want to use that for maybe a 50 amp RV, but the problem is if I have a guest pulling 50 amps, it would overload this because I'm already pushing 200 amps right there. So I don't want guests using that much power anyway. 78 Firebird Trans Am steering wheel, a real one. I had to get it off eBay because I used to have that car. So I'm organizing my electronics. I could do better, but it actually is logical in some way here, because this is more household stuff here, and then things, how to fasten. I'm switching over to these kind of wire fasteners, mostly for the RVs. This kind. Instead of wire nuts, and these are just horrible. Even if you heat shrink them, I don't trust this shit at all. This made in China BS. No. I don't like those either, so I'm switching to those. Look at the size of that air handler. That's why you're using a generator, plus the condensers outside, that's just as big. Have a fire extinguisher. Well, actually, you know what? It's okay there. You don't want it too close to the panel. If there's a problem with the panel, you don't want to be reaching for a fire extinguisher too close to it. So this is the 15.5 EER dual inverter 14,000 BTU air conditioner that is similar efficiencies to a mini split. Within the 90-day return period, I may return that back to Lowe's and get mini split so I can get my window back to normal there. I don't know. I really like that. It's very quiet and it's portable. I can move it around. I use a storm shutter panel on the outside, or actually right here, but as a barrier to the outside. I like that better than what came with it. The little slider thing that they want you to install is total garbage. So Lowe's sells this storm panel that's much better. Yeah, I recommend having a fire extinguisher near your panel. So I've already made a similar video to this, but this is just throwing out some more reasons why I just don't like the transfer switch idea at all. Even in my RVs, I don't like transfer switches. I always find a way around them. So the way around them in an RV is I simply install more robust battery power so I don't have to depend on plugging in someplace to power appliances. But in both the RV industry and the home electrical, most so-called professionals really praise transfer switches, and I am bucking the system. I do not like transfer switches. I think they have their place in some applications, but personally I try to avoid them as much as possible. This breaker here threw me off why they have a shared 20 amp breaker for the dishwasher and the under sink receptacle outlet. And I think the difference between a receptacle and an outlet is a receptacle is the center part, the receptacle where you plug into, and the outlet is more like the box around it, or the outlet could be all of it combined. But anyway, what I found out is there is a good reason why they did this, is because all of these share the same outlet. So if you want to work on the outlet, you don't shut off one breaker, you shut them both of them off to avoid being zapped. And as I mentioned before in another video, I have at least one breaker open, and I make it a 20 amp because I wouldn't use the 15 amp wire again, but rather 20 amp, so I can add one more thing. But I've got so much stuff already, I don't think I'll ever add another thing coming from the panel, but we'll see. Going back to some of the original main points of the video, on my label for the generator breaker, I put turn off all breakers without blue mark. So if somebody else is here, buys the home or whatever, they know, or they should be able to figure that out. Plus these warning stickers that came with the Interlock system, Interlock plate. I like doing this kind of work. It's just it's challenging. It's very difficult to figure out, but I like figuring it out. And a lot of it I've had to figure out on my own because the resources are very scarce. For example, the support for the Cincinnati electric transfer switch didn't exist. The company doesn't provide any support at all, at least at this time. And that's another reason why I got rid of the damn thing. I couldn't get any support because I wanted to figure out, is it possible to have a 120 volt generator somehow provide eventually a 240 power to the well, so I wouldn't have to get a 240 volt generator. But no one could ever give me a straight answer, so I just decided to go ahead and just get a 240 volt generator. A little bit of sort of unrelated information. I tore apart my Mercedes Sprinter van where I had a electric vehicle charging station hooked up. These were the components I took out of it that I may or may not put into the newer Ford van. I don't know yet. This is the Victron interface, so I can program the inverter on the Victron inverter. Actually, yes, since I have a that's still, I'm using the Tesla lithium ion cobalt battery for the new Ford van. I'm gonna have to put that in there so I can balance the cells on it, because I have to build my own BMS for the Tesla module, BMS battery management system. Actually, I need to put this in a prominent position and get ready to install that as soon as possible, because if those cells aren't balanced, that battery can explode. If it's, for example, Yeah, the cells, if they go above 4.2 volts each, 6 times 4.2, that would be over the threshold of the Tesla module and cause it to catch on fire or explode. And this prevents that from doing that. So the way this works, I got a special one that's that can handle 100 to 240 volts. That's really awesome. This is a really good product. So I can get power from any source, whether it's an EV charger or a wall outlet or a campground, and balance my Tesla cells with this thing. I need to get that thing hooked back up. I probably need to come in here and protect that wire from being exposed like it is. As long as the one next to it is also protected, it's okay, but you gotta watch out for those kind of things. Here you see I have caps on there to keep those two from getting touched to create an arc weld. You don't want an arc weld. A lot of people ask me what is the best brand of RC remote control charger. That's what that is, but it's being repurposed to balance the Tesla module. In my opinion, is the ISDT T8 is the best one. Get that one. If you have a Tesla module or plan on getting one, you should take note of those numbers right there. Kind of going back to household, I always complain about something and accuse humanity of being stupid and retarded, which it is often. To have something written sideways like this is absolutely retarded, just really stupid. A big no-no. No, people, no. Don't, you engineers, product designers, don't be this stupid. Put it the right orientation. If don't do dual orientation. Look, they got it here where you're having to read it vertically, and then here they want you to read it vertically also, combination vertical horizontal. I shouldn't use those terms in this case, but it's just all scattered. No. Why they use square 2-size screws for the panels, I don't know. Seems like that's one case Phillips would be just fine. Those don't have to be super tight. So just like if you had a transfer switch, where to plug the generator in outside is still the same. 30 amp or 50 amp inlet here. These days now, the more modern ones with a light that lets you know it's on or off. Look at this garage door. It's designed for to survive a hurricane. These are, look at these steel bars going across. A tree could slam into this garage door and it is not going to be breached. Also good for security. Pretty amazing. Look at this license plate. That's real. That was a real issued license plate. And it says Texas Space Commission on the bottom. That's a very rare and pricey license plate. Just trying to throw in some random interesting things in case you're bored. So this channel, I got 2 of them I was going to put on top of the Ford Transit to have solar panels mounted on those. I'm not sure I'm going to do it that way, or whether I'm going to use these rivet nuts. I think I'm going to choose this method instead, which means I'm going to lay out the panels on the roof and mark where the holes go and put these in the roof. But then I'll need to seal, well, I don't know. If it has a hole on the bottom, I won't be able to use this. Hold on. See, the hole on the bottom would allow the rain in. Does it really work that way? Then I won't be able to use them. Unless the hole on the bottom is sealed, but then eventually the weather will break through that seal. Unless I use this Mega Tack, I forgot what it's formally called, this stuff right here, nothing's going to get through that. But the water could collect in the riv nut and eventually cause severe corrosion. The water heater breaker had an on-call circuit next to it. And I don't know what that means. What's so special about the water heater to have an on-call circuit? If you know, please tell us in the comment section about that one. The Florida Power and Light has a sticker for the water heater that was there. I'll put it back. I just gotta use that double-sided, just use that light-duty double-sided tape for this. You don't need to use VRB. Maybe it's because the water heater has this box. Oh yeah, look. Notice. So something about this and the water heater, something about Florida Power and Light and the water heater, they monitor it. See that cable going out? Because I have a digital meter. Oh, my security light is out on this side. So here, my digital meter is connected to the water heater more than anything, and I don't know why. Why do they care about my water heater so much? I don't know. If you know, please leave a comment about that one. It's late and I ran out of interesting ideas, so I'm going to end it with asking for you to do all your little things and leave comments. Thanks.